Hey guys, my name is Larson Klibert. I'm currently a rising junior at Spring Hill College. I'm the lead TA for the chemistry department, and this year I'm going to be making videos for the entirety of the general chemistry course. There's going to be videos on every single topic. There's going to be practice questions, study guides, test prep, everything you could possibly need to pass the course. Everything will be in the link below. So let's get started. So first off, what is chemistry? So we know that chemistry is the study of matter, solid, liquid, gas, plasma, pretty much anything that you could see, touch, anything that has mass and takes up space, and how it changes. So the different types of reactions, how heat is transferred, how energy is transferred, things like that. And obviously, we know that chemistry centers pretty much all of the other sciences. It's a base for all sciences, and we can use it in many different types of applications. So if we're looking at a biology standpoint, our bodies are obviously made up of tons of chemistry, down to phospholipid bilayers, ion concentration gradients, constantly moving throughout our body, everything, ATP, everything is chemistry in biology. Physics, we're looking more at the ions, the particles, like how the particles move, why they move, their masses, things like that. And then technology, obviously it's a big one nowadays. Our phones, our computers, our lights, everything has chemistry in it. And I guess the point of this entire thing is to kind of say, it's a very important class. Like, chemistry is challenging and it is hard, but I challenge you to kind of like think about it in this type of way. Like, learning the basics and the concepts of chemistry can really impact your life further than just in the classroom. Like, you can kind of understand why things work the way they do. Maybe you could take it into cooking. You can learn some food chemistry. You can learn more about biology if you're a biology major, or physics if you're a physics major. Like, just take chemistry for what it is and try to change the way you think about it, because not all of this stuff is observable. Like, a lot of it is like so small where you can't see with the naked eye. So it's a lot of concepts you need to really think about and just kind of let sit. It's going to take a lot of time and a lot of practice, but I hope with these videos to help you all learn about chemistry and then to excel in the class. All right, so next up, we're going to dive into the scientific method and the types of data that you're going to see within it. So this is a lot more important for your lab class, but I figured it'd be important just to kind of like get into the details, give you guys a bit more info on it, because it is like your bread and butter of experimental analysis and research in itself. Some of you may be interested in research, so this is kind of like your most important thing. But starting off with the scientific method, you're pretty much going to start off with an observation. And for this case, let's just say we're talking about cooking a steak. So we might observe that we put steak on the grill and it cooks. Now, your question is, why does it happen? So you'll do your research and you'll look up why steak is made the way it is. Like, what types of things is it? Like, what types of muscle fibers? Why do they differ? Why do they cook? Things like that. And then you'll hypothesize and you'll say, I think steak cooks because X, Y, and Z. And then you'll do your experimental like stuff. So you're gonna like actually cook the steak. You're gonna see different types of groups. Like, maybe if you dip one in an acid or you dip one in a base. You're gonna see if you salt one, maybe if that changes anything, and you're gonna have a control group. So your control group is pretty much like your experimental group with nothing changed to it. So it's just your basic thing. So in this case, it'd be just throwing a steak on the grill, no seasoning, nothing else. And then you're gonna write down your observations. So with observations, this is where types of data come in. So we have quantitative and qualitative data. So in the quantitative data, it's gonna be like a number. So a type of weight, maybe the weight of the steak, or how long the steak took to cook. And then your qualitative is gonna be like your qualities, like maybe how did the color of the steak change? It went from being super bright red to brown. Were there any burn marks? Maybe there's some char on it. How did it taste? Did it taste differently if you were to salt it or not? Like, things like that. And you write those observations down, then you draw conclusions. The steak cooks better with this method because X, Y, and Z. And then obviously you're gonna write down your report and your analysis of what actually happened. So obviously this is a bit basic of an example, but when it comes to your lab class, you're pretty much gonna be doing this every single week, and you need to really get comfortable with the steps of it, how to do it, so that you can do well in your lab class as well. So now we're gonna dive deep into the SI units. So you may be asking, what does SI stand for? SI stands for the International System of Units. So back in the day, scientists, chemists, physicists all used to use the metric system. Obviously that was deemed as unworthy, and now we have the SI system. So we're pretty much going to be talking about anything that we can use to unitize any sort of data or amount or whatever we're trying to do, right? So we have our length, which is known as meters. That's your base unit. So if you're ever talking about just the SI unit of something, like it's easy test questions, they're gonna be like, what is the SI unit of length? You're gonna say meter. Like you just kind of like you have to memorize this stuff. It's gonna suck, but it's pretty important for the entirety of chemistry. So length is known as a meter, right? That's the base type of SI unit that we would use if we're talking about length, and it's abbreviated with an M. Then we go on to mass. Its base unit is a kilogram, and it's abbreviated kg. So time then goes to second. S, electrical current, which is known as an ampere. So like how many amps something has, like if you're using a speaker or something like that, how many amps is it gonna produce? That's abbreviated by capital A. Temperature goes to Kelvin, which is then abbreviated by capital K. Amount of like a substance or a solution is mole. This is very, very important in chemistry, so keep this one in mind. And it's gonna be abbreviated MOL. And then your luminous intensity, which is like how bright something can be. So like how like many watts does a light bulb produce? Like is it gonna be like too much or too little? That is abbreviated as candela, and it is CD. So these are all very, very, very important with chemistry. I'd say pay special attention to the moles, kelvins, kilograms. That's pretty much your main three with chemistry. And also knowing your volume. So volume, right, is pretty much how much three-dimensional area something takes up. So if we're talking about like a 2 liter of soda, the volume of the soda will be 2 liters. So your volume is going to be a liter, and it is abbreviated as L. This one is also very, very, very important for chemistry. So now we're going to our SI prefixes. So by using all of these things, we can now start converting them. Like how do we convert grams to milligrams, or seconds to milliseconds, or meters to kilometers, right? Like all these things are very, very important in the real world and also within the chemistry world. So we're gonna start off with our base, right? That's like our grams, seconds, meters, anything that's like just the basic unit, right? And then we have our deca, hecta, kilo, mega, giga, tera, which like are our basic units, and obviously this goes on forever, but these are pretty much all you'll need for this class. And they go 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 6, 10 to the 9, 10 to the 12. Now, I know it's a bit intimidating, but you will have to memorize this, and I'll give you a little way in a second. But in terms of the numbers, the way I do it is just 1, 2, 3, 6, 9, 12. Just know 1, 2, 3, and everything else after that is going to be just multiples of 3. So 6, 9, 12, 15, 18, and so on and so forth. And then same thing for down below. Deci, centi, milli, micro, nano, pico, 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, 10 negative 6, 10 negative 9, 10 negative 12, right? So all of this is pretty much our basic of our conversion from this unit. So the way that I remember it is by the abbreviation that each thing gets. T, G, M, K, H, D, A, base, D, C, M, mu, which looks like a U, and then N, P. So the way I do it is the great mighty King Henry died by drinking chocolate milk underneath pier. And pretty much every single test, like I wrote down this exact chart. It's great to just have in your brain, great to just have. It's gonna help you in a lot of your other classes as well. So if there's one thing I would say commit to memory, it's this right here. This is gonna help you a lot within general chemistry. So diving deeper into this, we can look at something like grams, right? So obviously everyone knows about kilograms. So we all know that if we were to have like 1 gram or one kilogram, right? That's gonna equal 1,000 grams, right? That's pretty basic. Now we ask, why does that happen? So if we look at our base unit, right? This is gonna be our 10 to the 0, which is just 1, right? So it's our basic unit. And we look at kilo, which is 10 to the 3. So we're gonna have what we would call a factorial of 3. So 10. So if we have one gram, we can do what's called dimensional analysis, and we can convert our grams with these types of prefixes to convert our gram into kilograms, right? So if we're looking at 1 kilogram, we know that 1 kilogram is equal to 1,000 grams. So this should be our answer. And we know that a kilogram is equal to 10 to the 3, and we know that our base is 1. So 1 kg is equal to 10 to the 3 grams. Now, we can obviously use our calculator, or we can just do some simple decimal moving. So if we have 1 and we move it 3 places, we add our zeros and our decimals at the end, we now have 1,000, right? So we also could do this on our calculator, which I will do really quickly to just show you guys that the answer is that. And you could see it is 1,000. So we know that 1 kilogram is equal to 1,000 grams. Now, obviously this is very basic, but this is a very, very, very important concept within chemistry. So I want to dive into this a bit deeper. So let's say we have, let's do something simple, right? Let's say we have something where it's 3 apples to 2 oranges, right? And let's say we're trying to do some math. We know that if we have 3 apples, we automatically have 2 oranges, right? So we want to figure out if we were to have 10 apples how many oranges? Right? So if we were to have 10 apples, how many oranges would that equal? I know obviously you're probably doing the math in your head, you can figure out the answer, but I want to kind of describe what dimensional analysis is to you. So let's say we have our 10 apples, so you're always going to start with your most basic unit, right? So whatever is in the problem statement, whatever the most basic thing is, the most basic unit, that's what you're going to start with. So 10 apples. And you're going to put a little multiplication sign. And you're going to put a fraction. So the point of this is we're trying to get apples and apples to be on the top and bottom, because then they can cross out and they can cancel. So we know that 3 apples is the conversion that we can use, the conversion factor. We know that 3 apples is equal to 2 oranges. And now there are oranges on the top, we know that these things can cancel because our apples cancel with apples. All we're left with is oranges. So now, if we do 10 times 2, which is 20, and divide that by 3, we get 6.66667 repeating, right? So we know that we're going to have 6.6 repeating oranges. And if you were to do the math in your head, you would know that we would have 3 apples, and you're multiplying, if we would do like a little, like a cancellation factorial. So 3 apples over 2 oranges is equal to 10 apples over X oranges. And we know that we can do 3 times X equals 20, or 2 times 10. So 3X equals 20. 20 divided by 3, again, is 6.6 repeating. So there's a lot of different ways you can do this, but in chemistry, this way, the dimensional analysis way, is going to be very important. Now, I know it's a bit confusing. It's going to take a lot of practice to get used to, but I will have some practice problems in the link down below, and then also we'll go over a few at the end of this session. All right, so let's do some practice problems to kind of reinforce this idea and to kind of get more comfortable with it. An important thing to chemistry is that this class is going to take a lot of practice outside of class. So a lot of these concepts and problems are going to be they may seem easy in class, but whenever you're kind of stuck with these problems on your own, it's a lot harder to kind of remember these ideas and bring them all together, because chemistry does build on everything. So like whatever you learn in chapter 1 is going to build for chapter 2 and so on and so forth. So if I can tell you anything on a way to study, just constantly do practice problems. I'll have a bunch of practice problems on the link down below, but your teacher will also provide you with practice problems in class, different things for you to do. So just keep in mind and always practice. So let's start off with number 1. We have 1,000 grams and we want to convert it to kilograms. So remember, as we stated before, dimensional analysis is very important for this class. And when we're doing dimensional analysis, we always start with our most basic unit. So in this case, it's grams. So we're going to start our problem off with 1,000 grams. And if you remember from before, grams must be on the top and the bottom so that they can cancel, and we want to be left with kilograms. So we know that our gram is our base unit. We know that our kilogram is our unit we're trying to find. So we know that 1 kilogram, which is on the top, equals 10 to the 3 grams. And we can get this from our chart. We see that kilo is equal to 10 to the 3 grams, where we have 1 kilogram on the top equaling 10 to the 3 grams. As we stated before, 1 kilogram equals 1,000 grams. And now if we do the math, we can see, if we pull out our calculators, we can see that 1,000 grams divided by 10 to the 3 equals 1. So we know that 1,000 grams is going to equal 1 kilogram, as we've stated before, right? 1 kilogram equals 1,000 grams, remember from before? So it's the same idea, we just worked it backwards, right? Keep in mind that we always want to keep our units on the top and bottom. So grams cancels with grams. All we are left with is kilograms, which is what we're looking for in the problem. Let's move on to number 2. So we have 1 kilogram and we're converting it, 18 megameters to meters. So remember, again, start off with our basic unit. We want to start off with 18 megameters, and we want to convert that to meters. So we know that mega is going to equal 10 to the 6 grams. So we can say that 1 megameter, because we need to go top and bottom, is going to equal to 10 to the 6 meters. And if we do the math, 18 times 10 to the 6, we get an answer of this. A lot of numbers. So I'll write that down. 180, 0, 0, 0, 0. So 18 million meters. Now, obviously, this has a lot of problems in itself, writing a number out as big as that, because whenever you're going to get to your decimals and things like that, it's just going to be super hard, and obviously, it's easy to mess this up. So what we can do, and to make this a lot easier, is we can convert this to what we call scientific notation. Now, on your calculator, whether you're using this one or another one, there's always going to be a mode known as scientific mode. And if I take this number in scientific mode and I press enter, it's going to convert it to scientific notation. Now this equals, it says on the calculator, 1.8 times 10 to the 7 meters. And all this is saying that if we have 1.8 and we were to move our decimal 7 places, so 1, 2, 3, 4, 5, 6, 7, we're going to have zeros like this, and we still get our decimal moves to here, we still get 18 million. So this is a very, very important concept. It's in a scientific notation. It's going to be very, very helpful for any sort of problems within this class. It's also going to make it just easier for you to remember different types of significant figures, which we will dive into in a future video. But yeah, always remember your scientific notation. It's going to make your life a lot easier. As you can see, I'd much rather write out 1.8 times 10 to the 7 meters rather than 18 millimeters. And if you're doing problems on tests and you're quickly trying to run through it, it's easy to mess this up and it's easy points gone. So always keep this in mind and do a lot of problems with this on your own. Try to figure out what it actually is and how to make it work. Now, going on to 1 kilogram to 1 microgram. So we're going from kilograms all the way to micrograms. Now the important thing is if we're converting any of these to any of these except the base, so if we're, like in this case, we're going kilograms to micrograms, we're not going from kilograms to grams, we need to go from kilograms to our base unit, and then from our base unit to micrograms. So to do this, we're going to start off with our 1 kilogram. And since we're going to our base first, we know that 1 kilogram is going to equal to 10 to the 3 grams, as we can see here. 10 to the 3 grams is equal to 1 kilogram. So we know that 1 kilogram is equal to 10 to the 3 grams, okay? Now, we also know that we're not looking for grams, so we need to get this to micrograms. So now we're gonna go from our base, which is our grams, all the way to our micrograms. And to do that, remember, top and bottom, so we're gonna have our grams on the bottom, we're gonna have micrograms on the top, and we know that 1 microgram is equal to 10 to the negative 6 grams, as you can see here. 10 to the negative 6 grams equals 1 microgram. So now, this entire thing, if we look at it with canceled units, we can cancel out our kilograms because of top and bottom. Now we have grams, we can cancel out our grams because of top and bottom, and we're left with micrograms. So now we throw this into our calculator. 1 times 10 to the 3. Oh, always, one more thing. If we're ever doing anything like this, right? So we have units on the top and the bottom. Always, always, always do all of your top units first and then all of your bottom units. So you want to multiply 1 times 10 to the 3 times 1, and then you want to divide by 1, divide by 10 to the negative 6. Because if you end up doing it top, bottom, top, bottom, top, bottom, things will get messy, things will get messed up. So just always go everything on the top to everything on the bottom. So in this case, 1 times 10 to the 3 times 1, which gives us 1 times 10 to the 3. And then you divide that by 1, and then divide that by 10 to the negative 6, which gives us 1 times 10 to the 9. Micrograms, which is what we're looking for. So if you want to write this all out, it'd be 1, and then you have 9 decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9. Zeros in between. And then micrograms. And we know that that would be a humongous number that honestly no one feels like writing out in the test. It's going to take up a lot of space, easy to mess up, like I said. So honestly, like I said before, scientific notation is your best friend. So this is our answer. And remember, we had to go from kilograms to grams and from grams to micrograms. So even if you're going from gigameters to kilometers, right? You're going from giga to base, from base to kilo. Always keep it in mind. Always know that if you're converting any of these units to any of these units except the base, you have to go through your base to get there. All right, here. Now we're gonna go to our last problem, 18 megameters, 2 millimeters. So starting off with our 18 megameters, we wanna get to millimeters. Now I know, like I said before, we need to get from, like we did for this one, we went kilograms to grams, then to micrograms. Same thing here. megameters to meters, meters to millimeters, right? So we're gonna have our megameters, which is gonna be 10 to the 6, and we're gonna do this. So 1 millimeter, or megameter, is gonna equal 10 to the 6 meters, right? These two cancel out. Now we need to throw meters in the bottom. So now we're trying to go to millimeters, which is gonna be 10 to the negative 3. So 10 to the negative 3 meters is gonna equal 1 millimeter. If we look at our units, they're gonna cancel out. Megameters in the top, megameters in the bottom, meters in the top, meters in the bottom. We're left with millimeters. So if we throw it in our calculator, we do 18 times 6 times 1, all of the top, then divide that by 1, divide that by 10 to the negative 3, because we always go all of the top to all of the bottom. So 18 times 10 to the 6 times 1 is going to give us 1.8 times 10 to the 7. And we're going to divide that by 1, and then divide that by 10 to the negative 3, which gives us 1.8 times 10 to the 10. Millimeters. And like I said before, if we want to write it all out, 1.8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Throw all of our fun zeros in there. Take away the decimal, throw it here. We are now left with another humongous number that I do not feel like writing on any sort of test or anything. So again, scientific notation is going to be your best friend. But yeah, I hope these practice problems kind of help you guys understand dimensional analysis and its concepts. So remember, if we're going any dimensional analysis, we're going to go units from the top to the bottom to cancel. So grams to grams here, kilograms to kilograms, grams to grams, we're left with micrograms. Here, megameters to megameters, we're left with meters, which is what we're looking for. Here, megameters to megameters, meters to meters, we're left with millimeters, which is what we're looking for. So dimensional analysis, like I said, is very important for this class. You're gonna be doing a lot of conversions with this stuff, with moles, with molar mass, whatever. There's gonna be so many different problems that involve these basic concepts. You need to make sure that you get these things engraved in your brain, because you will struggle with the rest of the material if you can't get this down. Work practice problems, like work the problems in this video, like anything you can do, just make sure you memorize this table, memorize this problem, like these types of problems. Remember how to do dimensional analysis with 1 and 2 steps. So here would be a 2-step, this would be a 1-step, and just kind of work on it, keep it in your head, and make sure you know it for the test.